will see the syllabus of microwave and radar. The course code is DET 3112. So for this course we have the 25 marks for term 1, 25 marks for practicals. So here after completion of course the two skill will be developed, that is intelligence skill and motor skill. So in intelligence skill, first is understand antenna parameters, second understanding microwaves, fundamentals and components, third learn microstrip and active components, fourth understand operation of pulse radar, then MTI and continuous wave radar system, and fifth explain the operation of a scope, PPA and ATD display. Then afterwards second one is motor skill. So in motor skill, first perform antenna parameter measuring, second describing microwave components and parameters, third describing microstrip components and parameters, fourth describing operation of pulse radar, MTA and continuous wave radar system, fifth describing the operation of a scope, PPI, ATD display. Then after completion of course, the student will be able to, that is in course outcome, first describe antenna parameters, second perform antenna parameter measuring, third describe microwave fundamentals and parameters, fourth describe microstrip and active components, fifth explain operation of pulse radar, MTA and continuous wave radar system. Then in unit number 1 we will see different antenna parameters and different types of antennas, like very low frequency antenna, low frequency, medium frequency, high frequency, very high frequency, ultra high frequency, then short wave frequencies. So in unit number 1 antenna and strip line definitions, antenna radiation pattern, near field, far field radiation intensity, radiation pattern, lobes, gains, directive gains, directivity, power gain, antenna efficiency, antenna resistance, polarization, practical antennas. So that antenna is basically, first one is very low frequency, medium frequency, high frequency. So very low frequency and low frequency transmitting antenna, then medium frequency and high frequency antennas, long wire antennas, loop antennas, practical of antennas like very high frequency, ultra high frequency and short high frequency. In that one we have studied the antenna like folded dipole antenna, Yagi-Uda antenna, helical antenna, discone antenna, lens antenna, microwave strip lines, microstrip lines, parallel strip lines, coplanar strip lines, shielded strip lines. Introduction to microstrip antennas. Explain the operation of a scope, PPA, ATD display. Unit 2nd waveguides, microwave fundamentals, microwave frequency spectrum, band designation and application of microwave in various fields, comparison of waveguides with transmission line, rectangular waveguides, propagation of waves through rectangular waveguides, reflection of waves from conducting plane, basic behavior, dominant mode at the conducting surface, dominant mode of operations, plane wave at conducting surface, parallel and normal wavelength, phase velocity, the parallel plane waveguide, cutoff wavelength, cutoff frequency, group and phase velocity, simple numerical, rectangular waveguides, modes, TEM0 modes, TEMN modes, TEMN modes, field patterns of TE10, TE20, TE11 modes, circular waveguides, advantage, disadvantage and application of circular waveguides. So in unit 2nd we will study different types of waveguide, application of waveguides, advantage of waveguides, and use of waveguides. In unit third, waveguide components means which type of components used in a waveguides. So in that one, multiple junctions, working principle and application of E plane, that is electric planes and H plane, magnetic planes, magic T and rat race ring, ferrites components, isolators, circulators and gyrators, accessories, flanges, rotating couplings, bends and corners, taper and twist, directional couplers, two-hole directional couplers, working principle and applications, directivity, coupling factors and isolations, horn antenna performance, parameters. Unit 4, microwave active components, microwave tubes, classification of microwave tubes, comparison with conventional tubes, two cavity clastrons, modulation and bunching process, construction and principle of operations, velocity, Applegate diagram, reflect clastron, modulation and bunching process, construction and principle of operations, velocity, oscillating modes, magnetrons, construction and principle of operation and application of 8 cavity cylindrical traveling waves, magnetrons, slow wave devices, that one helix traveling wave tube, construction and principle of operation and applications, compare the performance of clastron, magnetron and TWT, microwave solid state devices, TED, transfer electron devices, gun diode, construction, operation, principle, modes and applications, application of gun diode as an oscillator, avalanche transient time device, impact diode, construction, operation and application, pin diode, construction, operation and application, ISKI diode, tunnel diode, VI characteristic equivalent circuit, application as an oscillator, as an amplifier. Then unit 5 and unit 6 related to a radar. So radar fundamental, basic block diagram of radar system, radar performance factor, radar range equations, factors influencing maximum range, effect of noise, basic pulse radar system, block diagram and descriptions, antenna scanning and tracking, definition, types and principle of antenna scanning, horizontal, vertical, helical and spiral, antenna tracking, sequential, conical and mono pulse microwave dish antenna, feed mechanism or feed Cassegrain antenna, microwave. Unit 6, radar system. In radar system, Doppler effect, block diagram, operation and application of continuous wave Doppler radar, block diagram, operation and application of FM, frequency modulated continuous wave radar, block diagram, operation and application of MTI radar, concept of blind speed, display method, e-scope, PPI, automatic target detection, radar, beacons, application of radar system, sonar systems. So in textbook, reference book, first is Microwave Engineering by Gupta, Electronic Communication System by George Kennedy, Microwave Engineering by Das Anupama, then Microwave Devices and Circuits, Samuel Leo, Microwave and Radar Engineering Gautam A.K., Microwave and Radar Engineering Umesh M. Kulkarni, Radar System and Radio Aids to Navigation, Sen A.K. and Bhattacharya, Fundamental of Microwave and Radar Engineering Sharma K.K., Antenna and Wave Propagation K.D. Prasad, Antenna Theory Analysis and Design C.A. Balanis. Okay, thank you.